So good evening, everyone, and welcome to my presentation. First of all, I would like to thank you for coming here today. My name is Martyna Zarzycka. I'm backend software engineer at Sonalake. I've been working here for over a year, and also I've been working in SwitchedOn Fibre project since the beginning of this project. As you can see on the screen, our today's topic is business process automation with Camunda, based on SwitchedOn Fibre application. So the main aim of this presentation is to show you how we implemented workflow processes in our SwitchedOn Fibre application. I will show you the benefits of our approach, and we will get into the details about solving the business process and building an efficient, flexible, and fully testable workflow environment. Moreover, I'm going to tell you how our solution can provide better developer experience and also business analytics experience. I have divided my presentation into 6 main parts. I will start by describing you shortly what's the main aim of our SwitchedOn Fibre project. Then I will move on to the project architecture to point where we use system integration with Camunda. After that, I will tell you about the problems which we faced during the implementation phase. Next, I will focus on our system integration service, and I will tell you about the benefits of these problems. And after that, I will summarize everything. And finally, if you don't mind, I would like to leave the questions until the end of the presentation. So there will be time for Q&A session. And so please keep your questions until the end of the presentation. So let me first give you a brief overview of SwitchedOn Fibre project. So the Sonalake business support system called SwitchedOn Fibre is an intelligent telecom software. This application provides easy-to-use and fiber-focused software for fiber operators. Moreover, the application allows those fiber operators to automate processes across wholesale, retail, and enterprise services. So basically, it means that this application automates day-to-day activities of planning, ordering, using, supporting your fiber network. So this is the SwitchedOn Fibre flow. The flow consists of 5 steps: lead, quote, order, install, and operate. At the beginning, we have to discover if potential fiber operators are eligible for our address, and system has to validate our address and check all the possible services. After that, system looks for the qualified product for our address. Then we can choose some order and order it. The next step is about installation. So then system starts ordering installation process. And after that, the last step is about operating, so we can monitor our orders, subscriptions, billings, and everything what we bought. In this presentation, we will focus on the installation process. So I would like to describe you the problems which we faced when we were automating the installation process. But before I go into the details about installation process, I would like to show you our project architecture and tell you where we use our system integration with Camunda. And I would like to show you the services that are responsible for installation process. So this is our architecture. Please don't be overwhelmed by this picture. You don't need to follow every service on this architecture. So our architecture is event-based, and our application base is based on microservices. And according to the project flow, we have here our core BSS services like address management, qualification management, order management, and also order fulfillment management. Moreover, we have our observability services. So here we can find services like Grafana, Prometheus, Tempo, Loki, OpenTelemetry. Moreover, as I said, our application is event-based, so we have our event bus, and in this case, we use RabbitMQ. So, as I told you, we will focus only on the installation process. So, as you can see, these two services, order fulfillment management and appointment management, are responsible for this installation process. And those two services use system integration with Camunda. So, they communicate with our system integration with Camunda. So, let me come back to what I said at the beginning of the presentation. We faced some business problems during the implementation phase and also when we were gathering our project requirements. So these problems are related to automating our installation process. So first of all, we know that our core services like appointment service and order fulfillment will have set of generic functions. So we know that every external fiber operator will have to use those functions. So, for example, we know that appointment service will have functions like search a free time slot or reserve an appointment. And we know that every fiber operator will have different implementations of these functions. So we would like to make it very easy for developers to implement those functions by having a standard generic interface for those functions. So the question is how to provide a consistent and well-defined set of business features to an external client. The second problem was that we know that we will have to integrate with any number of external services because every fiber operator will provide us its external services. So our core applications, our core services will have to communicate with their services. So moreover, we should be constantly prepared to attach these services to our application and communicate with those services. So the question is how we can create a flexible environment to integrate with any number of external services and be prepared to add them in any time without interrupting our core services, our core code. And the last problem was about our installation process. Our installation process is very complex and very complicated. It consists of many steps, and we would like to avoid creating one massive workflow because it can cause some problems like it's very hard to test it, very hard to update it, and it's very hard to debug it. So the question is how to implement our complex installation workflow process to have it as flexible as possible. The solution to our problems was to create a very flexible service which can solves our problems and also can integrate with, can connect with Camunda. And all the external services. So that's why we introduced our system integration service. And let's take a look at the benefits of this service. So first, we split our installation process into smaller workflows. As I mentioned, massive workflows are very hard to test, and workflow tools don't have any great toolset for debugging. So providing smaller workflows gives us the opportunity to easier test it or debug it. So moreover, it's easier to update and provide new feature to these steps in our installation process because we have smaller workflows. Okay, and also, as I told you, we know that we will have to integrate with any number of external services, and our fiber operators will have different solutions for some part of this installation process. So right now, if we have smaller workflows, it's easier to provide different approaches for these workflows because we don't need to interrupt the entire big flow. We can just update one workflow, one smaller workflow, so we can just interrupt the smaller part of this workflow. So then let's talk about the communication between services. I mentioned that our application will have set of functions, and every fiber operator will have different implementation of this function. So we provided a well-defined, event-based, and type-safe interface. And this interface is attached into our core service as a Java plugin. And every external service provided by fiber operator has to implement this interface and provide its own implementations of the functions. So it's easier to test it because right now we can very easily add a new client into our application because every new client has to just, implement these functions. So it's also very safe for us because we have a set of functions and we know that everyone has to implement it. So the last area, it's about providing low-code development. So right now, adding a new client into our application is very easy because we don't need to interrupt our core code. We don't need to changing our code in our core services. We can just attach a new client as a Java plugin. Every external service is provided by this fiber operator. We can just attach it into our application, and we can just test this new plugin and check the integration with our application. So we don't need to. We are not forced to check the entire flow and everything in the application. We can just test this part. Moreover, right now, if we have this generic set of functions and we know that every external client has to implement this interface, it's very easy to implement, to model Camunda workflows because we can just attach a reference to the function from external service. We don't need to add any code into the Camunda workflow. So it's easier for developers, but thanks to that, modeling a Camunda workflow can be done not only by the developers. So it's just like, creating a workflow by using existing blocks. We don't need to have any programming skills. We can just, using the existing functions. So moreover, smaller workflows are easier to monitor, test, and debug. So it's better developer experience because of this approach. So now I would like to show you the system integration architecture. We use this architecture for our two services, which use Camunda, so for order fulfillment and for appointment. But I would like to show you an example of appointment architecture, and this is pretty the same for order fulfillment. So as you can see, system integration, this one, is the main service which uses Camunda. And we have to attach into our service, we can attach any number of external services. So here we can find services provided by fiber operators, and here can be any number of these services. And what's important, every external service implements the interface for appointment plugin API. And in this plugin, we have just defined the set of functions which have to be implemented by every external client. And as you can see, this is the last plugin, and our appointment plugin API has to implement our core main base plugin. And base plugin is the most generic plugin, and every external service uses it, not only appointment, but also in architecture, in order fulfillment architecture, we can also find this base plugin, because every plugin has to implement this the interface from this plugin. But I would like to tell you a bit more about every step of this architecture. So now let's talk about the main generic plugin, which is base plugin. The goal of this plugin is to define a common type-safe API for a set of different implementations of some function. And in the interface of this base plugin, we can find three definitions: feature, function, and execute. So as you can see, this is the interface of the base plugin. Here we can find three definitions: feature, function, and execute. So feature function describes the name of the function. So as you can see, function. So in function, we can find something like create an appointment or find available time slot. So this is just the name of some function. In feature, it's here, and feature points to a group of many functions from one family. So for example, in feature we can have name like our appointment integration service A. So here we can find also the name of the target or our fiber operator, something like zero appointment or opener appointment. And execute, here we can, this is just the implementation of our function. Okay, so I would like to take a look at the plugin request, this object which is sent as an argument in the execute method. So in the plugin request, we can find two elements, process args and action args. In process args, we can send global process variables, so every variables from our Camunda workflow. And in action args, we can provide any other action-specific arguments. The next element in our architecture is appointment plugin API. So in this plugin implements the base plugin API, and in appointment plugin API we can find the definitions of our functions which we have to use in our appointment. So let's take a look at it. So as you can see, this is one of the example classes from appointment plugin API. And as you can see, this class implements plugin function, so the class from this base plugin. And in appointment plugin API, we have to just implement the definitions of function. So as I told you at the beginning, we know that in the appointment service, every external fiber operator will have to implement some specific functions, and every external fiber operator will have different implementations of these functions. So this is one of the functions, find available time slots. So in this plugin, we have just the definitions of our functions. And every external service provided by fiber operators will have to implement these functions. So let's take a look at one of the example external service. So as you can see, this is one of the classes from our appointment integration A. And this class extends the base time slot search function. So this is the class which you could notice in the appointment plugin API. And in this service, we have to add the information about the feature name. So as you can see, in this case, we have appointment service A. And we also have to provide the implementation of the defined function. So in the execute, we can see the implementation of find time slot function. Moreover, I would like to mention that we override this execute method, and we can provide in the argument any object, and also we can return in this execute method any object, and the returned object will be added into the process variables in our Camunda workflow. So right now, I would like to show you how we can use this feature and function in some of the examples. So I would like to show you how we can use it in the Camunda workflow. So work order is one of the order fulfillment workflows. So this is one of the workflow for our installation process. And work order is a workflow where we manage the actual work. So in this process, an engineer is going out to someone's house, drilling the walls, checking the cables, all the connections. So that's the main aim of this workflow. And I would like to show you here how we can use in the Camunda workflow our approach with using feature and function. So as you can see, this is one of the service tasks. And in service task, we have to provide two inputs, feature and function. So the value of the feature is order service A, and the function is find details. So it's everything what we have to do in the Camunda workflow. System integration will look for this function in one of the external services, and we'll call this function. So that's everything what have to be done. And as I mentioned, our system integration is our architecture is based on an event. So we were forced to provide some functions which can support our events. So we added these functions like erase an event and listen on an event. So let me elaborate the raise an event function. So if we want to raise an event, we have to attach into the Camunda workflow a signal intermediate throw event, and we have to provide into the properties all the data about this event which we want to raise. And that's everything what we have to do. Afterwards, the system integration listens on signal intermediate throw event and gets this data provided in the properties, creates a new object and sends it into the event bus. So in this example, you can see how we have to implement this in the Camunda workflow. So as you can see, this is very, very simple example. And we have to create signal intermediate throw event. And we have to provide this for inputs. So this is our generic inputs. So we have to always provide them. Raised event message, raised event subtype, raised event type, and raise event. So in the raised event message, we have to provide the payload of our event, or our message, which we want to send to the event bus. In the subtype and type, subtype type will be added into the event headers, and this is our generic approach for our project architecture, that we always send this to headers in every event. So we have to just provide here the information about subtype and type, and these values will be added into the event headers. Moreover, system integration gives us the opportunity to listen on our events. So what we have to do to implement it? So in the Camunda workflow, we have to attach a message intermediate catch event, and we have to provide the unique message ID. But this is not everything what we have to do. We have to also attach all the information about this message into the mappings YAM file, and this file is provided by our system integration service. And now it's everything. And afterwards, the system integration listens on incoming event, matches the event from our event bus and with the data provided in mappings YAM file, and saves the data from the incoming event into the Camunda process variables. So this is the example, and here we can see how to implement it to listen on some event. So as you can see, we have to create message intermediate catch event, and we have to only add the global message ID. So in this case, this is get appointment by ID. And please remember this ID, because right now I would like to show you what we have to implement in the mappings YAM file. So this file contains all the information about the events that have to be handled by some workflows. In this example, you can see Camunda message. So here we have to provide this ID of the message. We have to also define what workflow has to handle this event. So we have to add the process key of the Camunda workflow. Moreover, to recognize the event which has to be handled by the Camunda, we have to point out the headers of the event. So in this case, we have to handle the event with these headers, with type and subtype. Moreover, we have to also define the values which we want to save into our Camunda workflow provided by this incoming event. So as you can see in these message variables, we can provide what we want to save from the event into our Camunda variables, process variables. What's important here that I showed you that we have to provide process key. So it only points out to the name of the process, but we know that we can have, I don't know, 100 events with this process key, but this particular event has to be handled by one workflow. So we can also provide entity reference, and entity reference, it's the unique ID of the workflow. So we can provide the key from the incoming event and compare these values, and then our system will only match our incoming event with one particular workflow. It is possible that incoming event message will not contain this information about entity reference, so will not have any information about workflow ID, and it's possible that this some event has to be handled by many workflows. So we can attach the key from incoming event and the key from process variables from the Camunda workflow and compare these values. As I mentioned before, our approach, we split our installation process into smaller workflows. So right now, our installation process consists of many smaller workflows. And if we want to run our installation process, we have to join these smaller workflows into one installation process. And our application has to know which workflows have to be run and in which order. So to perform this, our application receives the request with all the information about the workflow plan, so about the workflow IDs which we want to run, and about the order of these workflows. So let's see at this request. So as you can see, this is the snippet of our example order fulfillment plan. And I told you that every fiber operator can have different approach. So if we buy some product and the owner of this product, so the fiber operator, can have different workflow for this step. So in this case, in this example, so this is our request, we have to provide all the information about the installation process. And in the plan items, we have the workflows which we have to run. So in the specification ID, we have the key of our workflow. Moreover, in this request, we can also define this kind of information like some workflow depends on other workflow. And also in the request, we can provide information about the process variables, which have to be added into our Camunda workflow. So to illustrate what the entire order fulfillment workflow can look like, let's take a look at these pictures. So on this picture on the left, we have our installation process in progress state. So as you can see, some of the processes are finished, some of them are waiting for activation. And as you can see on this picture, this is completed order installation process. So once all the sub-processes are finished, are completed, then we can mark our entire installation process as completed. Well, this brings me to the end of my presentation. So to summarize, I would like to briefly go through the benefits of our approach and tell you about the possible drawbacks of this approach. So as I told you, right now it's very easy to attach a new fiber operator to our application because we can very easily attach new plugin into our application. Moreover, it's also helped us in the test area because right now we can very easily test it. So our developer experience has also improved because of this approach. Moreover, we don't need to interrupt the core code. We don't need to add any new code into our core services. We can just attach a new module into our application and test it. Moreover, building a new workflow can be done not only by developers, because as you could notice, we have to also define in the Camunda workflow the information, the references to some functions from external services. So it's very easy to create Camunda workflows for new fiber operators. On the other hand, what can be possible cons of this approach? So as you could see, our architecture may be hard to understand because it's very big, and we tried to make it as flexible as possible. But in my opinion, this is every microservice approach problem. And we have done our best to resolve this problem by automating most of our documentation. Also, we added automation tests, and also we used our observability platform. So we solved this in this case. And moreover, I told you that our approach gives us an opportunity to very easily test every part of our application, but can be hard to test the entire application, especially when we want to do it locally. But also, we can also solve it by providing some automation approach. In our case, we use Docker Compose with all the required containers which have to be run when we want to test some function. So there is also a solution for that. And now I will be happy to answer your question which you gathered during this presentation. So does anyone have any question?
Which version of Camunda you use here?
Okay, so the question was which version of Camunda we use right now. So we are using still Camunda 7. We haven't migrated to the Camunda 8 because we would like to wait for a while before we do it. And what's the reason for that? We didn't do it because Camunda 8 is very different than Camunda 7. And it uses different database, so we would like to wait for it, and especially that Camunda 7 will be supporting by the next 5 years, so we would like to wait for a while. Okay. Okay, so if you don't have any question, I would like to thank you for this presentation, for your that you are here today for me, and thank you very much.